Okay, welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. In this video, we are going to discuss the lead code question number 2610, which says convert an array into a 2D array with conditions. I will not go into the details, but the question says that you have been given an array nums, which is something like this. Suppose 1, 3, 4, 1, 2, 3, 1, right? If I try to map the frequency, then 1 is occurring 1, 2, 3. 1 is occurring 3 times. Similarly, 3 is occurring 1, 2, 2 times. Similarly, 4 is occurring 1 time and 2 is occurring 1 time, right? This is the frequency array. So if I try to read, what do I have to do? The question says that we have to convert this array into a 2D array. Now this 2D array actually has some condition. What does it say? 2D array should contain only the elements. Okay, no problem. Each row in the 2D array contains distinct digits. So when constructing the 2D array, you know a 2D array contains rows and columns, right? And columns, right? So it is saying that each row, in fact, in each row, there should be only distinct integers, right? Unique values. And the number of rows in 2D should be minimal. The number of rows should be minimal. Okay, no problem. And we have to return the resulting array. If there are multiple answers possible, return any of them. Okay, we are lenient that way. Now, suppose this array is given to you 1, 3, 4, 1, 2, 3, 1, and the answer is given to you as 1, 3, 4, 2, 1, 3, 1. It can be seen that 1, 3, 4, 2, all elements are unique, 1, 3, all elements are unique, 1, all elements are unique. All elements are unique. And you may try, but it is not possible to follow all the three conditions and yet get a 2D representation with less rows, with less number of rows. Three number of rows is the minimum you can get, right? Is the minimum you can get. Now, how can we solve it? How can we solve it? Okay, so 1 is occurring 3 times. 1 is occurring 3 times. My basic approach says if 1 is occurring 3 times, I will require at least 3 rows because each one will get a different row because each one cannot be in the same row, right? Two ones cannot be in the same row. So, I am saying each one will require at least 3 rows, right? This completing all of the ones will require at least 3 rows. That is frequency, right? Similarly, 3, how many rows will it require? 3 requires 2 rows, right? It will require 2 rows, which is also equals to its frequency. 4, 1 row, 2, 1 row, no problem in that, right? So I can see that 3 rows are the maximum required in the case of 1. I will wrong to say that 3 rows is my answer? I am saying that 3 rows will be my answer for the number of rows I will be needing to construct the 2D array. Am I wrong here? Am I wrong? I'm saying 3 rows is the answer of the size of the array, size of the 2D array, right? Because 3 rows, I will insert 1, 1, 1. Now 2, I have to insert 3, 2, 2, 3. So 3, 3. After that 4, I will insert 4 here and then I will insert 2. So you can see 1, 3, 4, 2, 1, 3, 1. That is how I get 1, 3, 4, 2, 1, 3 and 1. 1, 3, 4, 2, 1, 3 and 1. So what is the approach I use here? What is the approach I use here? So approach 1, fairly simple, guys, fairly simple. I will construct the frequency array. I will construct the frequency map. You can use an unordered map here, frequency map. Now what will you do? So you have 1 occurring 3 times, 3 occurring 2 times, 2 occurring 1 time and 4 occurring 1 time. My basic approach says that traverse, right? So I will say while true, what will I do? Let me change the size of the thing. While true, what will I do? I will say first vector of int, let us say I will store it in the cur, right? What will I do? I will traverse the map. So for auto it in MP, what will I do? If it dot second, that is the value of the number of remaining in the number of the elements remaining in map is equals to 0, it's not equals to 0, that means it is present in the map, its frequency is not 0 up till yet. Then what we will do? Cur dot push back it dot first, cur dot push back it dot first, and then decrease the frequency, and mp of it dot first minus minus, mp of it dot first minus minus, right? Now when will I break this loop? Because I'm using while true, I will say that if cur dot size is equals to 0. That means there was no element present which has a frequency positive, right? In that case, break. In that case, break. Else, what you will do? Answer, which is your 2D array dot pushback, right? This is my approach. If you don't understand it, don't worry, I will be running it for you. See, 1 3 3 2 1 4, right? So what I'm saying is, I will traverse while true, right? So I will traverse and I will make a array. I will make a array. Suppose this is my empty array. This is my empty array, right? What I will do, I will traverse. So 1 has a frequency of 3. I will change that to 2 and I will push 1 here. Okay. 3 has a frequency of 2. I will change that to 1 and I will push 3 here. 2 has a frequency of 1. 0, 2 here. 4 has a frequency of 1. 0, 4 here. After this traversal, this will be my array. This will be my first row of the 2D array. So I will push it into the answer. So my 1, 3, 2, 4. Right? Moving forward, I will again construct an empty list. Again, 2. Change it to 1, push 1 here. 1. Change it to 0, push 3 here. Right? And you can see 0, 0. So it will not get pushed because the frequency is already 0. They have already been used in the 2D array. So I will push 1, 3. Moving forward, I have this array, right? I will see only 1 is left, so 1 is converted to 0 and 1 comes here and 1 comes here. So I will push 1 here, right? And this will be my 2D array. I can simply return my answer, right? I can simply return my answer. Talking about the breaking of the loop, so you can see after all zeros, when I will create an empty list, I can see that nothing will get pushed up. So I'm using if cur dot size equals to equal to 0. In that case, break. Otherwise, push it into your answer. Push it into your answer. So I hope that will work for you, right? What is time complexity, guys? What is time complexity? So you can see in the case of this operation, we were actually running it as much as maximum element required, right? Maximum frequency required. So suppose these are n elements, these are n distinct elements. It is actually O of distinct elements multiplied by maximum occurrence, maximum frequency, I can say maximum frequency. This is the time complexity of the problem, right? Space complexity is O of distinct elements, right? Because we are using a map to store the answers, right? We are using a map. Now, can we optimize it? Can we optimize it? Yes, I can optimize it. How? So approach 2. You are here, you will get results, right? Approach 2. What will I do? So I have the frequency map again. 1 is occurring 3 times, 3 is occurring 2 times, 2 is occurring 1 time, and 4 is occurring 1 time. This is the frequency map, right? Let me change the 3 and I write it nicely. Yeah, 3 is occurring 2 times. Now what I will do? So the array given to me is, suppose 1, 3, 1, 2, 1, 3, 4. Suppose this is the input array. This is the input array. Let me clear that out. Let me say that I have an empty map right now. I have an empty map. Now what will I do? I will say that let me create a vector in answer. That is my 2D array. Something looks like this. I just have to push vectors into it, right? Now I will start traversing the array. 1. I encounter 1, right? Now, 1's frequency will get updated. So 1 has a frequency of 1 right now, right? Now I will see that this 1 will get into the position, like if I will say that there are n rows. This is first row, second row, third row, fourth row, fifth row, right? I will say this one will get in the row 0. Suppose this is my 0 index row, 1 index row, 2 index row, 3 index row, 4 index row. Why? Because this one is occurring first time, so it will be occurring in the 0th row. So I will push it. I will make a vector and I will push 1 into it, right? Moving forward, 3. 3's frequency is also 1. So I will push it into the 0th vector only. 3. 1. Now 1's frequency get changed to 2. So I will push it into the 1 vector. 1 comes here. 2. I will push it into the, because 2's frequency is 1, I will push it into 0. So 2 comes here. 1 again. Its frequency gets changed to 3. So 3 minus 1 is 2. 1 will be getting here. 3's frequency is 2. So I will push it into the 1. So I will 3. Okay. Now 4's frequency is 1. So I will again push it into the 1 only. So it will come here. Now I will close the list. These lists are not formed and my answer will be 1, 3, 2, 4, 1, 3, 1. 1, 3, 2, 4, 1, 3, 1. It is highly optimized. Why? Because I'm just using an O of n traversal. O of n traversal to get all the elements and store it side by side into my answer array. I hope that is not a mistake here. I hope that is clear to you, right? I hope that is clear to you, and it is a far better approach than the approach one. So we'll be continuing with that only. And code. Okay guys, so here we are. So what I will do, I will first create the unordered map to store the frequency. Unordered map into int, right? Name it as mp. Now vector of vector int answer. Moving forward, I will traverse the map. I will traverse the array, sorry, for int I equals to 0. I less than nums dot size I plus plus, right? Let the element be element equals to nums of I. Now the frequency, I will first increase the frequency. So int frequency, int element plus plus, right? Increment the frequency. Now at what position do I want to put the element? So position equals to mp of ele minus 1, right? Now it might be possible that this array does not exist in the answer, right? The size of the answer is still less than the position I want to insert. So I will just check it. So answer dot size is less than equals to position. Why equals to? Because I go to the n minus 1 position, right? So I will have to put the equals to sign also. So what I will say, I will say answer dot push back an empty array. Why empty array? Because then I will be able to push back to the correct value inside the empty array, right? To make the size greater than the position, that such that index does exist in the answer. So now I will say answer of position dot push back. What do I push back? The element, right? And after that, return your answer. Return your answer. Let us try to compile and run it. Hope it will work fine. And it is running. It is running fine. Let us try to submit it as well. In the meantime, do consider subscribing to my channel because it means a lot to me, and you can see it is getting submitted easily. So thank you for watching. We'll meet tomorrow with a new video. Till then, keep watching, stay coding, stay safe. Okay, have a nice day. Bye.